Hello, good guys. Welcome back to my channel. Let's Code with Kundan Kumar. If you are new to my channel, I'm Kundan Kumar. In today's video, we are diving into an essential Java concept called the typecasting. If you have ever been confused about how Java handles data type conversions, this video will clear it up for you with a super simple water glass analogy. Please don't skip this video. Watch it till the end to fully understand the concept in a way you will never forget. This lesson is going to cover about what is the typecasting, type of typecasting, working principle of typecasting, which I will use the water glass analogy, and will all be seen by demonstrating practically. And if you are new here or haven't subscribed at my channel, please hit that subscribe button to support and encourage me to create more amazing content for you. Let's jump right in and make a Java typecasting super easy to understand. So first thing first, we should know what is the typecasting. So typecasting is assigning a value of one type to a variable of another type is known as a typecasting. Let's take an example. We have one variable called integer x assignment 18, and we have another variable called float type, which is a y equal to 25.45f. If you want to assign, so here you can see in this example, x is being assigned with the y is float, but x here is integer. You are assigning float value into the integer. That is the meaning of typecasting. Assigning a value of one type to a variable of another type is known as typecasting. Float data is going to be assigned into the integer. Another example, y assignment x, where we are assigning integer value into the float. So this nature called the typecasting. Let's go and see type of typecasting. Java supports two type of typecasting called the widening casting, which is a implicit automatically. Java supports automatic widening casting. What is the widening casting? We'll see here. Widening casting means you are going to store a small data into the bigger data type. So here understand, you can see smaller to bigger means small data is going to assign into the bigger size of the data type. That is the main widening, from a smaller to bigger. Another is called the narrowing casting. Narrowing casting means Java does not support explicit, mean indirectly, automatically narrowing casting. You have to cast manually by writing the program. So narrowing means you are trying to assign big size of data into the small size of data. Okay, so you can see bigger to smaller. That is a two types of Java support to this two type of casting. Just understand widening casting. Widening casting conversion is allowed in the following cases. First, byte, which is a 1 byte data size, can be converted into the short, integer, long, float, or double. You can see here byte is only one byte, and it can be 1 byte data can be converted into the short, which is a 2 byte, integer is a 4 byte, long is 8 byte, float is a 4 bytes, and double is a 8 bytes. So smaller to bigger. Again, like this, short can be converted into integer, long, float, or double. Thus again, short is smaller than integer, long, float, or double means smaller to bigger. Character can be converted to integer, long, float, or double. Again, character is 2 bytes, integer is 4 bytes, long byte is 4 bytes, float is 4 byte, double is 4 byte. So smaller to bigger. Integer can be converted into long, float, or doubles. Likewise here, long can be converted to the float or doubles, and the last float can be converted to double. So that is automatically Java supports. Let's understand the working principle of the widening typecasting. Let me take these two glasses of water. One is a small, you can see the byte, consider as a byte. This byte having the range from 128 to 127. Guys, you have not watch my video, you can go to my channel and you can watch this video of data type. You can see, please watch this episode 5, understand the data type, what is the data type, and then you can come back to watch this video. So please, if you have not yet watched this video of data type before understanding the typecasting, please go and watch this my video here, and then you come back to these videos. So I'm taking two glasses of water. One is small and one is bigger. This small is representing the byte, which is 2 bytes, and range is -128 to 127 because of signed integer. Integer is 4 bytes, which can have the data range called the -21 blah blah blah, and this is the one. So what we can say, we are talking about the widening typecasting which Java supports automatically. That's called the implicitly. So if I want to pour the water, you can see, imagine, imagine you have a small glass and a big glass. If you pour water from the small glass into the big one, it fits perfectly without a spilling over. You can see it fits automatically without a spilling over. This is just like a widening typecasting in Java. When a smaller data type, like here we are talking about the byte, you can see here, is converted into the longer one, which is an integer, no data is lost. Okay, so let's see practically what I mean to say. So let me open the IntelliJ In this IntelliJ IDE, I am going to write a simple code that will demonstrate widening typecasting. So guys, I am using the IntelliJ IDE. Okay, if you have any other choice of your the IDE, you can choose. You can choose VS Code, you can choose NetBeans, you can choose the Eclipse. But in my video, I am using the IntelliJ IDE. Okay, so let me go here and create one file here, call that Java class. I can say here typecasting demo. I have created typecasting demo. Let me go here and say here we need to must write the signature of the main method public static void main string args. Correct this spelling mistake, opening and closing. Here I am going to create one variable byte x equal to number 125, because byte range is minus 128 to 127. It can fit here. Okay, fine. So I am going to create one variable called the integer. This integer is y. I am going to keep inside this one integer one like a x. This called the widening typecasting. Why is it widening typecasting? This is because I am here. Let me terminate. This x is a byte and this y is an integer. So I am going to put in a small data into the bigger one, means a small glass of water I am pouring into the bigger one, and it's automatically that Java supports. So there is no loss of data. So here we can say no loss of data. Okay, so let us print system dot out dot print ln. So I'm going to print both x is equal to understand x equal to what, I'm going to add plus x for the concatenation. Then again I'm going to copy paste. I'm going to write another code called the y equal to by is integer, and I'm printing the y here. So I'm going to run this. What will happen? X value will be printed, which is 125. Now x is I'm going to assign into another variable which is a different type integer. Byte is also numerical, integer is also numerical, but byte is a different data type which is having the 2 bytes, 1 byte size. Integer is 4 byte size. So I'm going to put the small number of data into the bigger one, which Java supports automatically, means without loss of data. So I'm expecting both are printing same value. So let me do it, run this one. So I'm going to run this, and you can see here, you can see both are printing same value. So this is called the widening. Why widening? Because byte is smaller than integers. Fine guys, let me go here because byte cannot store more than 127. So let me add simply 127. Okay, I will show it more than 120. Let me run here 120. See, system is giving compile time error. Why? Because the range of byte data type is cannot cross more than this range, means this x cannot accommodate beyond this range. Likewise for the integer also. So guys, if you again I repeat, if you have not yet watched my data type videos, please go and watch this video. In this video I have explained what is the range, how to calculate the range of each type, and what is the range of each specific data type. Please watch there and come back to this video. So now that's why it's compile time error. So let's go back and write simply 125. So Java supports. I have not done any explicitly manually typecasting. Java is supporting. That's a widening typecasting. So let's go and see what is the narrowing casting. Narrowing conversion is a lot in the flowing cases. Means short means narrowing means bigger data is going to assign into the smaller size of the data type. That is narrowing, means bigger to smaller. The short can be converted to byte or character. Here short is a 2 bytes data size, and byte is only 1 byte, character is a 2 bytes. That is a character, so it can be signed. That is a character can be converted to the byte or short. Sorry, it is yes character. This is a character. Then integer also can be converted to the byte, short, and character. Let you know that integer is 4 bytes, byte is 1 byte, short is 2 byte, character is 4. So bigger to a smaller. Okay, long can be converted to the byte, short, or character. In the terms of size, long is a 8 byte. Okay, and then byte is 1 byte, to short is 2 bytes, and character is also 2 bytes. Float can be converted to the bytes, again short, bigger to smaller. Double can be converted to byte, short, character, integer, long, and float. This can be, I'm talking about based on the data size, the data type size. So double is 8 bytes, can be converted into the 1 bytes, 2 bytes, 2 bytes, 4 bytes, long bytes, and 4 bytes and 4 bytes. It means when you are converting the bigger size data into the smaller size data, a smaller size, then there will be loss of data. In narrowing, there is chances of loss of data. To understand this one, let me show you some analogy. Working principle of narrowing typecasting. Let me take a glass of water. So I am taking here again similar glass. One is a byte, one is an integer type. Integer means bigger size. This is a range. Means in this integer type glass, this range of data can be accommodated. And this is a byte glass, means this range data can be. So now my case is that what happens if you pour water from big glass, this big glass into a smaller one, this in byte one, it a spill over. So when you pour this glass of water from here, time will come that it will spill over, spill out that water. It means losing some water. What is happening? Because you have a bigger glass of water, you are pouring that, considering that glass is full, and you are pouring this water, it means the water cannot be fit into the smaller one. So there is a spillover, a spill out, overflow. So that's called the loss of water. This exactly what happens in narrowing typecasting. When larger data type like a integer is forced into a smaller one like a byte, it can lead to data loss, unexpected results. So let's understand this analogy as well with examples. Let me demonstrate it. So here I am going to consider I have one variables integer a equal to 129, which is a is holding. Consider I have another variable called byte b, and I am assigning a into byte b. Byte is 1 bytes storage, and the range of byte is 1 minus 128 to 127. But here a is holding 129, which is beyond the byte range. But I am doing so here. I am narrowing typecasting. How? Java does not support automatically this narrowing typecasting. So you can see here I am writing in bracket, in parenthesis, byte. This shows called the manual typecasting. I am converting bigger size of the data into the smaller size, called the narrowing. A is a bigger size in terms of data size because integer is 4 bytes and byte is only 1 byte. Here also A is holding 129, which is a 129, and byte cannot hold 129. So when you assign 129 into byte, then there will be loss of data. So what happens? Understand that one. So what I'm going to do here, so let me show you practically first. I'm going to do here. So allow me to change this one. Okay, allow me to change. So I'm going to simply change. I'm writing here integer a equal to 129, and I'm writing byte b, okay, is this one equal to, I'm writing a, and this one here a is integer, this one, and here b is byte. Here you can see here the system is giving the errors because, check it out, what is that? Show context here. cast expression to byte. They're thinking, please you need, if you want to convert integer into byte, you have to manually typecast. That is a hint they are giving, this one. So I'm going to cast it in byte form. Byte. I want to say computer, please convert this integer data type into the byte. But keep in mind, this byte range is minus 128 to 127. I have explained in the data type videos. So now, but one A is 129, which is beyond this range. Means you are, when you are assigning the big data into the smaller one, there is a loss of data. Definitely there is a loss of data. Okay, so what we are going to do, understand, let me see what output is coming. So let me print system dot out dot print ln. Okay, let me write here a equal to 129. Okay, then I'm going to write a system dot out dot print ln. Okay, here b equal to what plus b. Let me see what output are you telling me. You are expecting might be a equal to, sorry, not a equal to 29, sorry guys, plus a. So you might be expecting a equal to 129 and b equals to 129. Just I'm making scenario. You might be you are expecting, but there could be the loss of data. Let's see what happens. So look at this one, age 129, because this is integer, integers can hold 129. But when come to the byte range is minus 128 to 127, and you are assigning a into the byte which is 129, but b is holding, see the output here down in the this one down here, check it out guys, b equal to minus 127. What happens? There is a loss of data, because I am assigning 129, but system is able to hold only minus 127. So what is the happening? What happens here? So let us understand this one with the glass of water analogy, and I will demonstrate everything technically. So let me take you here. That is what I am writing here. Suppose we have integer equal to 129. I am extracted this line from my code. Byte b equal to byte a. This is a explicitly or manually we are typecasting integer a into the byte. So actually you are getting output minus 127 for the b. So what is the happening in the background? So I'm explaining you that one. So step one, what computer does, first of all, computer represent that 129 into the binary, which is integer. Okay, so this decimal number 129 is stored in 32 bits. Why 32 bits? Because 129 is integer and 129 is integer. So at this level, this integer is 4 bytes. 4 byte means 1 byte equal to 8 bits. So 4 byte equal to 32 bits. So this 129 will be written into the 32 bits. So how? So this is my first 8 bit. 1 2 3 4 5 6 7 8. I have used different color just to make you understand. Okay, so first 8 bit, second 8 bit become 1 2 3 4 5 6 7 8. So 8 plus 6 16, another third octet, and then fourth octet. So total is 8 plus 8 16 plus 8 24 plus 8, this green one, 32 bits. So 32 bits are there. So let me write the positional value. When we talk about the bits, means it is a positional value. So first bit having positional value is 1 2 4 8, like this, in multiple of 2 up to here. So I'm going to write this 129 into the binary format. So I'm writing in the binary format. So you can see here 129 can be written in binary format like this. How? 129. So you can see this is a positional value of each bit. 128 is here. So 128 plus 1 is 129. So 128 is involved in 129. So 1 is here and then 1 is involved. So 1 is here. Rest filled with 0. Okay, so what you are doing, 129 is going to assign into the byte which is a smaller size, which is 1 bytes. 1 byte equal to 8 bits. Okay, so let's see the second step what happens. So what you are going to do, actually you have a bigger size integer data. Look at this back side. Again I will go back. You can see 129 means integer, means 32 bits means data is going to pour into the 1 byte data. So there will be loss of data. That is why we are getting output 1 minus 127. So what is the happening? So let's understand. I converted this to 129 into the binary. So this is a binary number. Please pause the video, try to understand What is this? I'm using the shortcut method called the positional value of the binary and I have calculated. Otherwise, you can use the divide 129 divided by 2 repeatedly, and then you can find the remainder and arrange it. You will find this binary number. So let's understand this one, what is the happening. So you can see here all the 432 bits, 8 bits, 8 bit, 8 bit, 8 bit. These colors I have brought it here is a part of integer. So this is when you are pouring into the smaller. Why pouring the smaller? Because you can see here again back, integer is, you are pouring integer data into the byte, means bigger data into the smaller. Byte is a smaller 1 bytes, the integer is 4 bytes. So when you are pouring this bigger data into the bigger glass into the smaller glass, when you push, what happens? So you can see here, you can, when I'm pouring here, okay, first data will go, fine, then next data will come here and the previous data is going to spill out. Once a spill out, the followed by the rate next bit of data, and then previous data is spilling over. Okay, then this is gone, then last bit, the last bit of the data is coming. Once done, it will be a spilling over, because last bit 8 bits. Okay, so what is the happening? Hope you understand. Let me go back again and see here what I'm trying to say here. This 8-bit data, you can see this 8-bit 32 bits data, considering as a integer, you can see it is an integer, the data is there. So you're pouring the data, so we'll pour it. Okay, the leftmost 8-bit is going, okay, water is full. Then next 8-bit data is coming. When it's filling, the previous data is overflowing. Then another data is coming, the third 8 bits data is coming in a spilling over. Then last, the data of 8 bits coming, and then it's spilling over, and this is the data is going to stay. So still it depends on the what is the range of the data. So let's see here what happens here. Second step, you are going to truncate the last bit. You are going to truncate this data, because this is 8 bits, byte is 1 byte, so data can store this bit 1 byte, because 8 bits means 1 byte. So this is a data you are going to take it here. You can see this data is going to keep in this byte. This small glass is standing for the byte. So this is a data is going to be truncating. So I'm truncating the 8 bits byte. How? Check it out. That is what we are doing here. Check it out. So byte in Java only has 8 bits, that is 1 byte. So only the last bit are kept in that byte. That is the last bit, 8 bit. What happens next here? You can see, though there's interpreting the 8-bit value. So you can see the first bit, this is a first bit, you can say leftmost bit in a 8-bit sign integer, because that is a sign integer, represent the sign positive or negative. So this bit, first bit, stand for the sign, it is a positive or negative. So if this first bit, the leftmost bit of the 8-bit, because that is the data we are truncating, so this 8-bit is truncating. So this bit, if it is a 0, it is a positive number, and if this bit, you can see the leftmost is 1, it is a negative number, 2's complement. So fine, so let's go step 4 and see. This is a bit we are truncating. Okay, so converting the 2's complement to decimal. So what to find the decimal value of this one? This we can see, this is 129, you know it. We invert this bit and add 1. What happens? So first of all, you invert this number, which is already in the integer, into the ones complement. So you are going to convert ones complement. So what is the ones complement? It means 1 becomes 0 and 0 becomes 1, means 1 turns into the 0 and 0 turns into 1, you can see. So that is the 1. Once it become a ones complement, this is a ones complement, you need to add 1 into the this ones complement, add 1, that is the one, add 1 to this number. Once you add into this number, you are going to get 2's complement. So this is a 2's complement, you can see this is the number we are getting. So when you get this number, this is a 127. How? You can see this is a binary number of 127. How to know it? You can just add, because this excluding the last bit, this first bit, we can say leftmost bit, if okay, all the bits are 111, so we can say 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is equal to 127. That is a this is a binary number of 127. Now you can see in the beginning, you can see here your first bit was 1 at the in this one. So we can say apply negative sign to this 127. Why? Because since the first bit or leftmost bit was 1, Java interpret it as a negative number. Thus, the value stored in B is negative 127 instead of 129. So guys, hope you have understood. I believe if you have not, please keep rewind, pause, understand the analogy of the glass. That is an unforgettable demonstration, guys, I believe. So guys, now time to quiz. So quiz number one, questions one. Pause my video. Don't run this output, okay? This is a question I'm writing. You can see integer a equal to 256. And I'm saying I'm putting into the byte means for this data is going to put in the byte. What could be the output? My answer, my request to you is that don't type this program in computer and say this is the answer. I kindly request you to take a pen and paper or whiteboard with marker on the screen, make 32 bits, write the 257 and try to truncate that value that you want to use it in that one in 1 byte data and see what is your resultant by following this process. By what is your result by following this a step 2, a step 3, a step and a step 4. What is your results? And get the answer done on your papers. Once you find some answer, then type these questions in your computer. Run it and see system is giving your expected output or not. That is a learning, because computer will give some answer, but how that answer, that computer return that answer, how that computer give that output, you have to learn. So that is a question one, guys. Now question two. Please write the answer, write the calculation, get the answer done and put in your in my comment box to confirm that you are watching my video and you are trying to practice these quiz questions. I will be very happy to see your comment in below. If you have still any doubts, any questions, relevant questions, please put in my below in the comment box. I will be happy to respond to you as soon as possible. May God bless you. Please, if you are new to my channel and you have not yet subscribed my channels, please you do subscribe, because doing research, making slides, preparing contents takes lots of efforts and time. Guys, please encourage me. May God bless you. See you in the next video. Thank you. Bye bye.